Assalamu alaikum everyone. Today I'll discuss with you lesson 10.2 plus 10.3. In this lesson we have arithmetic and geometric sequences. Now sequences mean what? Sequences are the pattern, right? So for example, if I give you different patterns, for example here is 3, 6, 9 and so on. And here is 3, 9, 27, 81 and so on. And I'm asking you determine which one is arithmetic, which one is geometric in these given series. So always in series we represent the numbers by terms. And for example, this is A1, this is A2, this is A3 and so on. And here this is A1, this is A2, A3, A4 and so on. Now I want to check which one is arithmetic, which one is geometric. So first let me check this is arithmetic or not. So for arithmetic we need to find the common differences. How can we find the common differences? A2 minus A1, meaning second term minus first number. So 6 minus 3 is 3. 9 minus 6 is also 3. So you can see the common differences are same, right? The common differences are same. And we represent the common difference by D. So here D is equal to 3. So it means this is arithmetic sequence. So if in any sequence the common difference is same, then it means that is arithmetic sequence. And we represent the common difference by D. So here D is equal to 3. Now go to the second one. In the second one, if you find the common differences, 9 minus 3 is 6. 27 minus 9 is not 6. It means the common differences are not same. So in this case we have to find the common ratio. How can we find the common ratio? In common ratio we have to do division instead of minus. Here we did minus in common difference. But in common ratio we have to do the division between the numbers. Yani A2 divide by A1. So 9 divide by 3, which is 3. 27 divide by 9, which is also 3. 81 divide by 27, 3. So all the common ratios are same. So it means this is geometric sequence. And we represent the common ratio by R. So here R is equal to 3. So in arithmetic you have to find the common difference. If the common difference is same, that will be arithmetic. If in any sequence the common ratio is same, then it means that sequence is geometric sequence. Common difference we represent by D, and common ratio we represent by R. So this is the first example to determine that sequence is arithmetic or geometric. Now let's go to the second example. For example, if I give you the sequence, let me take the same sequence. For example, 3, 6 and 9. And I'm telling you to find the 10th term of the given arithmetic sequence. Now, in the question I mentioned that this sequence is arithmetic and I'm telling you to find the 10th term. This means what? 3, 6, 9 and so on. And we have a lot of numbers. Now I am asking you to find the 10th term. So you can find any term in arithmetic sequence by using a formula. What is the formula? An equal A1 plus n minus 1 into D. So whenever they give you sequence and they are asking you about to find the term, any term, you will use this formula. In this formula, n mean what? N mean which term you are finding. So we are finding 10 term. So it means A10. A1 mean your first term, which is 3. Plus n is what? 10, right? So 10 minus 1. And then D mean common difference. And you know how to find the common difference. Second number minus first number, right? So 6 minus 3 is what? 3. 6 minus 3 is 3. So it means my common difference is 3. And after that, just you will give this to the calculator and you will write the answer. Give this to the calculator and you will get your answer. This is for arithmetic sequence, how to find the term. For example, if I give you the geometric sequence, for example, let me take this sequence 3, 9, 27, 81 and so on. And I'm telling you to find the let's suppose same thing, 10 term in the given geometric sequence. Now I mentioned in the question that it's geometric, so no need to check. Okay, no need to check it's geometric or no, because I mentioned that it is geometric sequence. What is the question? The question is find the 10 term. So even in geometric you can find any term by using a formula. What is the formula for geometric? It's an equal a1 rn minus 1, r raised to the power n minus 1. So just replace the values, only the formulas are different. Other things are same. What does it mean by n? N mean your 10th term which you are finding. So a10 equal a1 mean your first term. R is what? R is ratio. Here D was difference. We find the difference. Here R mean ratio, common ratio, because geometric sequence. So how can you find the common ratio? A2 divided by A1. So 9 divided by 3, which is 3. So here R is 3. And N is what? 10. 10 minus 1. And then give this to the calculator and you will get your answer. Okay, this is for the term. Now let's talk about the sum. Sometimes they will say find the sum, or they can say evaluate. They can give you the sequence, or they can give you the sigma notation, and they can say find sum or evaluate. Sum and evaluate, both are the same thing. Okay, for example, if they give you the question as a sigma notation, and they are saying sigma here nk is equal to 1 to 13, and whatever is given here, let's suppose 2k plus 1. Okay, in another question they give you sigma k equal 1 to, let's suppose 10, and here is 3 into 1 over 2 raised to the power k. Now, and the question is, they can say find the sum, or they can say evaluate. Now here they did not say that this is geometric or arithmetic. So how I will know that the first one is geometric or arithmetic? Now you can see here k is not as a power, so this is arithmetic. But in the second one, k is a power, right? Whatever the letter I am using, that one is as a power. So whenever the variable is, or the letter is as a power, then it's mean this is a geometric sequence. But in which sequence the k is not a power? In which expression the k is not a power? It means this is arithmetic sequence. So this one is arithmetic, this one is geometric. Again, why? Because here the which letter I am using, that one is as a power, but this one is not as a power. So this is arithmetic sequence. Now how can I find sum? So for the sum, for arithmetic sequence we have a formula, and for geometric sequence also we have a formula. For arithmetic sequence, what is the formula? It's Sn equal n upon 2 a1 plus an. This is the formula to find the sum of arithmetic sequence or evaluate the arithmetic sequence. Okay. Now what does it mean by n here? N mean your number of terms. What is how many terms you have? So here this means k, the numbers starting from 1, and how many numbers we have? 13. So it's mean n is 13. Number of terms are 13. And now n is 13 upon 2 a1. Now how can you find a1? You can find your any term in the sigma notation by replacing whatever the variable is here. And here we have k, right? By replacing k here in this expression. So for example, if I want a1, so I will take this expression, which is 2k plus 1. And if I am finding a1, so I will replace the k value, the starting k value. What is the starting k value? 1. So I will replace k by 1. So 2 times 1 plus 1, which is 3. Right? So a1 is 3. Now an mean what? An mean a13, right? Because here is 13. So this means a13. But I don't have a13. So I have to find a13 also. How I will find a13? Same expression. Because we are doing the same question. You will take this expression and you will replace k by 13. So 2 times 13 plus 1. Give to the calculator. So 13 times 2 is 26 plus 1, which is 27. Now replace the value here. Instead of A13, now give this all to the calculator and you will get the answer. So whenever they give you the arithmetic sequence as a sigma notation or as a sequence, and they are saying find sum or evaluate, you have to use the sum formula. This is the sum formula. Now for geometric sequence, how I know this is geometric? Because the letter is as a power. Now in the geometric sequence, we have two types of sequences whenever we are doing the sum or we are evaluating the expression. So the first sequence is whenever the sequence is finite sequence. If the sequence is finite, then the formula will be different. And if the sequence is infinite, for example, if here is k equal 1 to infinity and here is 1 over 2. Now here is, what is the difference between both? This is finite because I know how many terms I have. But this is infinite. I don't know how many terms. It start from 1. But till how, I don't know. So here my formula will be different. And here, because it's finite, the formula will be different. Okay. So in both you can see the letter is a power. So both are geometric. Okay. In arithmetic, we don't have this thing. In arithmetic, whatever the sequence is, you will use this formula for the sum. But in geometric, you have to check it's finite or infinite. If it's finite, so what is the formula? The formula is we are finding the sum, so it will be Sn. So it's Sn equal, what is the formula? A1, 1 minus r raised to the power n upon 1 minus r. Now just replace the values. Now in geometric, it's easy to find the A1 in the sigma notation. How easy? Where you have a power, on which number you have a power, that is always your r. And which number you are multiplying, which number is in multiplication, that will be your A1. If nothing is here, then A1 will be 1. So here, what is my A1? 3. And then 1 minus, what is r? 1 over 2. And raised to the power what? 10. Right? Let me write down. Here, A1 is 3. 1 minus r is 1 over 2 raised to the power 10, because n is 10. We are finding the sum of 10 numbers, right? So 3, 1 minus 1 over 2 raised to the power 10 and divide by 1 minus 1 over 2. Just replace the values and give this to the calculator, and whatever is the answer, you will write here. Again, what is the formula? Sn equal A1, 1 minus r raised to the power n, 1 minus r. A1 will be which number you are multiplying here, which number is in multiplication, that will be your A1. If nothing is here, A1 will be 1. Okay, and where you have a power on which number, that will be your R. Just replace the values and you can get the answer. Now let's talk about the infinite series. Let me remove from here 3 so you will understand about when A1 is 1. So for example, this is the sequence. Now I know this is geometric because the variable is as a power. But this geometric sequence is infinite geometric sequence. So in this case, whenever you have infinite geometric sequence, sometimes the sum is possible and sometimes no. And sometimes I can evaluate, sometimes I cannot evaluate. It depends on the R value. If it's finite, you can do. You can find the sum directly. No need to check the R value. But if it's infinite, you have to check the R value. Here the R is 1 over 2, which is less than 1. If R value is less than 1, then it's mean you can find sum. But for example, if the R value is more than 1 or equal to 1, then you cannot find the sum. We will do in the next question that one, okay? Here, R is less than 1. R is 1 over 2, right? Less than 1, so we can find the sum. Now, because the sequence is infinite sequence, so what will be the formula? Sn equal A1, 1 minus R. This is the sum formula for geometric sequence whenever the sequence is infinite sequence. And now just replace the values. A1, I told you which number is multiplying here, that will be your A1. Nothing is here, it's mean 1. And 1 minus, what is R? Where you have a power, which is 1 over 2. Give this to the calculator and you will get the answer. Now, for example, if you have the geometric sequence, infinite geometric sequence, k equal 1 to infinity, and here is, let's suppose, 2 raised to the power k. Now this is geometric because the power is as a variable, right? Now in this case, because it's infinite, I told you whenever infinite geometric sequence, you have to check the R value. Here the R is 2, which is greater than 1. So in this case, the sum is not possible. You will write not possible. So in infinite geometric sequence, you have to check the R value. If the R is greater than or equal to 1, then it means the sum is not possible. We cannot evaluate, we cannot find the sum. So this is about in the geometric sequence how to find the sum or how to check the sequences arithmetic and geometric. See you in the next video. Thank you so much.